Okay, this is a video about adding and subtracting polynomial expressions, and basically it is a carryover from Math 2, and let's go ahead and see what lies in wait for us and what we expect to accomplish. Okay, so we're going to look at basically some ideas that we should be familiar with, like this business of, okay, um, like terms, okay, so that means is that we have to go ahead and call upon our past knowledge that we've learned in other classes like Math 1 and Math 2 to go ahead and collect up like terms, and then adding and subtracting polynomials, which we already done in the other classes. So this is a little bit of review. And then, of course, there's an application in regards to geometry and then some other cost analysis stuff that we take it a step further here in Math 3. So let's dive in. Okay, so here are some of the vocabulary words that we're going to need to know. And a monomial is going to just be anytime that you have a term, whether it's going to be a constant, okay, it's going to go ahead and be a variable, any combination of which is going to be a monomial. Now, when we end up with a polynomial, we have the monomials that are being if you look at this one, and not to skip ahead here, is that guy is going to consist of two monomials, so that we have 3x and we have 5 there. And when we string them together to make an expression, that basically means is that we're going to go ahead and connect the monomials together, and basically by addition or subtraction to create an expression. Okay, standard form just basically means this next part right here, where we are arranging the polynomials from order to greatest to least. So that would go 3 power of 3 power of 2 power of 1, and technically, it's kind of weird, but x to the power 0, which is like a 1, we don't usually write that. So it would just be something like the constant would be very last. A term is going to be each part of the polynomial that's separated by addition or subtraction sign. And like terms, just to go ahead and review, they have to have the same variable raised to the same power. So for example, here's an x, and here's an x. They are both raised to the first power of the x's, so that means is that we'd have 7x. This is x squared and x squared. So if I were to combine those together, that means is that I would have 28x squared, and so forth. So it has to have the exact same variables in order to gather them up in some type of way. And then lastly, something that we should be pretty good with is this distributive property stuff. So that basically means is that any number that is going to be in front of these parentheses, we're going to kind of like do those little lines there, and that's going to be 3 times 2x, which is going to give me 6x, okay, and 3 times negative 5, which is going to give me a negative 15. Okay, so that is pretty much the bare bones of that stuff, and we're just going to carry on over into this business of the prerequisite skills. Okay, the prerequisite skills are pretty straightforward. And so you need to go ahead and be able to add, subtract, multiply, and divide positive and negative numbers. So the way that I look at this is that, just going from left to right, I know that a negative 7 plus 5, that's going to give me a negative 2. And I'm adding a negative 2 to that. And so if I'm adding 2 more negatives to an original of 2 negatives, I'm going to go ahead and get a negative 4. And likewise, if I were to go ahead and start off with this one, we just kind of rewriting a little bit. This is the way that I would do it. Is that a negative 5, and then I'm subtracting 5 from it. So that means is that I'm going to go more negative, and that's going to give me a negative 10. And likewise, I want to use the distributive property, or negative negative, that's going to make this positive here. And so that's going to be a negative 10 plus 4, which I know is going to give me a negative 6. The distributive property is going to work like this, okay? And one of the things that we got to make sure that we're going to do is that we're going to put things in standard form. So that means is that the highest power of the exponent first, okay? And so I did the distributive property correctly. However, to put it in standard form, we want it to look like this, with the highest power first. And likewise, this guy over here, okay? So we're going to end up with a negative 18x plus 4x squared minus negative 6. Okay, so this is kind of all out of order. And I know that this is going to be the highest exponential term. And so I'm going to put that first. And then next is going to be that guy, which is raised to the first power, which is going to be 18x. And then finally we have this constant in the end. And that's that. So now that we just kind of reviewed some very basic prerequisite skills, let's jump into the lesson. Okay, this first one, we're just finding the sum of, oops, and apparently I paged back on accident. We're finding the sum of these two polynomials right there. Okay, so these ones that they say, go ahead and add these guys up. Okay, so the first thing I'm going to do is that since I'm adding both of those together, I'm going to drop the parentheses and rewrite the polynomials with everything all laid out so I can group up the like terms. Okay, so after I do this, I'm just going to start gathering up the using the like term definition. Is that I'm going to start gathering up the terms of this big old polynomial right here that are going to be the same variable raised to the same power. So this is a convenient way to do it. I look for the highest power, which happens to be this guy. And so I'm going to bring that down, and I go 16y to the fourth, because there's nothing else that is raised to the fourth power here. Next, I'm looking for the next highest power. Looks like I have a 7y to the third. And so I'm going to, and that's a positive 7y to the third, so I'm going to load that in there next. 14y to the second. Okay, so it doesn't look like I'm doing a whole lot of gathering right now. I'm just kind of like organizing. But this is the fourth time, and it has 4 lines under that. And I just do that to kind of like keep things straight and organize my work. Is that I'm going to get now a negative 6y plus 14y, which is going to go ahead and give me positive 8y. Okay, and then finally I got these two constants hanging out here. I want to add those guys up, so I got a negative 4 right here plus positive 3, and that's going to give me negative 1. Okay, and so that's how we want to do those out, just gathering, adding up those polynomials and making sure that it's put into standard form. Okay, for this next one, we're just looking at this business of perimeter. And perimeter of a figure, to go ahead and review, is this going to be the distance around the figure. So that means is that all those linear distances. And so what we're looking at is that I'm finding, okay, what is going to be the perimeter of this this figure here. And so I want to go and say that this is going to be the width and this is going to be the length. So I know that the perimeter of this particular figure is going to, I'll have 2 w's plus 2 lengths. Okay, now we know that those widths and lengths are represented in x's as shown from the diagram. So what we want to do is substitute those out and then use the distributive property to clean things up. And so the perimeter is, we have 2 widths, and I know that the width is going to go ahead and be those guys. So we have 2x plus 2's plus 3x plus 6's. And now we just need to go ahead and clean that thing up, and that is going to give us the perimeter as a representation of x. So we're going to do the distributive property, So I got the perimeter equals 2x plus 4 plus 6x plus 12, collecting like terms. And so to finish this thing off, I have perimeter equals, and now I got 6x and 2x, which is going to give me 8x, and then I have the constants, which are going to go ahead and give me 16. And so that is the perimeter represented in terms of x. Now, what it's asking us to do is to evaluate when x is 7. So as a preview, I'm going to make this into a little bit of a function here, and I'm going to say the perimeter with respect to x is going to give me 8x plus 16. I know that you have seen this before in Math 1 and Math 2. So therefore, if I want to evaluate the perimeter when x is 7, I'm going to plug 7 in and then knock this thing down from there. And I know that we have done plugging numbers in for functions and function notation that you're seeing right here. And so let's go ahead and say the perimeter when x is 7. It appears, last time I heard, x times 7 is 8 times 7 is 56 plus 16. So it looks like at the end of the day, and I'm going to erase some of this stuff out because I kind of painted myself in a corner here. And so it's over there. So I'm going to get, what, 72? And since it said that this is feet, I'm going to go ahead and put some feet on that. And so it looks like the perimeter when x is 7 is going to be 52 feet. 72 feet, sorry about that. And so, yeah, that's how you do that. And we're going to be building functions based on perimeter and evaluating them, and later on some area stuff in units to come. So, on to the last example. Okay, the next example needs a little walk-up music, I suppose, or some introduction. Is that one of the things that we're looking at, before we read the problem or understand anything, is that if you're looking at to make profit and you're producing something, you have to go ahead and analyze the cost, okay, and the revenue. Okay, and the revenue basically is going to be how much you can go ahead and sell this particular object for, how much you get it, your service or whatever it is. So the cost, of course, is the cost of making, and let's just call it an object, making the thing. Okay, and the revenue is how much you can sell the thing for, whatever it is. And we used to call it a widget. I just call it a thing. And so it would make sense is that we would have the cost, okay, of the revenue, okay. So how much you can sell the thing for minus the cost is going to equal profit, okay. And so, for example, say you're making a taco, and you can make a taco for 50 cents, right? And so you would have 50 cents here, and you would end up with the revenue, sell that taco for $2, okay? So your profit is going to be great. You'd make $1.50 per taco because you had to pay 50 cents to go ahead and make the thing. $2 it sold it for, and so $1.50 goes into your pocket. So we're going to take the same concept here, and we're going to take a look at how to find this polynomial that is going to represent profit. Okay, so the first thing I want to do is that I want to take a look at the revenue. Okay, so how much am I going to get per bicycle sold? And it looks like that X is going to represent the number of bicycles that are being sold or produced, etc., etc. So the revenue, okay, which is going to be this guy right here, that means is that I'm going to bring in this much money per bicycle sold. And so if I make one bicycle, that means is that would turn into a 1, that would turn into a 1, okay? And the revenue would be what, like $512, okay? So the cost is going to be, and I'm going to put this around parentheses, the cost to go ahead and make these guys is going to go ahead and be this guy right here. So we're subtracting the cost, which is this right here, okay? And once I get done with those, I think that was at 100,000, okay? So once I go ahead and I subtract them out and put it in standard form, I'm going to have a function with respect to x, okay, that is going to give me the profit, okay? So I know at the end of the day I'm going to get a profit with respect to x of, and I'm going to subtract these things out, okay? So I know that I'm going to do the distributive property and collect like terms, okay? And I'm going to continue the work down here because I'm a little bit out of room. So because I want the profit with respect to x. And so I would have 2x squared plus 10x plus 500. And now I got to flip the signs on all those guys. Okay. And then we got this big old 100,000. Oops, I didn't flip the signs on those, did I? I'm going too fast. Sorry. And so I would have flipping the sign on that and flipping the sign over here. Okay. And so therefore, collecting up like terms, I have this and this, which is just going to give me, and I'm going to put it over here, x squared. And then it appears that these guys are just going to cancel out, right? And now I got a positive 500 minus 100,000. Yikes. And so that is going to give me a minus, and it looks like that is going to be 99,500. Okay. So that basically means is that there's my profit, okay? I have to go ahead and looks like I have to sell quite a few bikes, because if I'm understanding this, that this x, when I square it, has to be greater than this part right here, 99,500, because I'm going to subtract that amount in order to make a good profit, okay? So let's take that profit function and put it to the test, like it's saying, is that if the company has only enough materials to make 300 bikes, should it make them? And so, rather than just saying, yeah, it should or no, let's go ahead and take a look. So I'm going to put 300 in to our profit function and see if this is going to go ahead and give us a good return. If not, then we probably shouldn't make it. If it gives us a good return, then we probably should make it. So after computing this out, we're going to get a negative 9,500, okay? And that is going to be dollars. And so would it make sense that they want to go ahead and just do 300 bikes? And the answer is no, because you would be losing money. You'd be taking a loss. Okay, so they would need more material to go ahead and turn a profit. So say, for example, they end up getting more material, and I know that this isn't part of the problem, but just to hammer things home, is that, and we had enough material to make 400 bikes instead of just 300. So we can see what kind of profit we would make then. Hopefully it would be positive. So it looks like if I had enough to make 400, I could turn a profit of $60,500. Okay, so we would just have to balance being able to have the materials on hand to make those, and this is going to be a gain here of that much. And so there's going to be a threshold in which we have to be able to make enough bikes to go ahead and offset the cost with the revenue to make some profit. Okay, So, basically, that's how you do that. We're going to see some of the problems in the practice that's going to be assigned with this. And yeah, so thank you for watching.